The future of anti-aging won't come from creams, miracle pills, or cryogenic sleep pods. It will come from manipulating the molecular levers that evolution installed in our cells billions of years ago. Ancient switches like TOR, target of rapamycin, and AMPK, AMP-activated protein kinase, that control whether the body spends energy on growth or preservation, repair or replication. These two cellular pathways don't just govern metabolism, they shape how we age, how we fight disease, and how long we stay biologically young. And now, science is on the brink of turning them into precise therapeutic tools. TOR and AMPK are part of the nutrient-sensing infrastructure that cells use to make life-or-death decisions. TOR promotes growth when nutrients are abundant. AMPK activates during energy stress, shifting the body into repair mode. For most of human history, the dynamic balance between these two helped our bodies adapt to feast and famine cycles. But in today's world, constant eating, low physical activity, nutrient overload, TOR stays chronically switched on, while AMPK is rarely triggered. This imbalance accelerates aging, fuels chronic inflammation, impairs mitochondrial function, and sets the stage for age-related diseases like diabetes, cancer, and neurodegeneration. In the next decade, we can expect three major categories of intervention to reshape how we manipulate these ancient switches: nutritional, pharmaceutical, and epigenetic. Nutritional interventions will go far beyond generic advice to eat less. Precision nutrition will use personal biomarkers, wearable tech, and AI-driven meal planning to create AMPK-activating dietary patterns tailored to the individual. Intermittent fasting, time-restricted feeding, and low-protein/high polyphenol diets will become the default for metabolic health, not as fads but as strategically programmed nutrient stress. Foods rich in compounds like EGCG, quercetin, curcumin, berberine, and caffeine will be prescribed not as supplements, but as functional dietary inputs to modulate TOR and AMPK in real time. On the pharmaceutical front, TOR inhibitors like rapamycin and its analogs, rapalogs, are already showing potential in extending lifespan in animals and improving immune function in humans. But these drugs are blunt tools. The future lies in selective, pulsatile dosing, where TLR is temporarily suppressed to trigger repair without shutting down essential growth functions. Imagine once-weekly TOR off days built into your calendar, synchronized with immune challenges or post-injury recovery. Similarly, AMPK activators, beyond metformin, will become more refined. Drugs will be designed to target specific tissues, brain, liver, muscle, without causing systemic stress. Some will bypass energy sensing altogether and directly mimic the downstream effects of AMPK, like boosting autophagy or increasing mitochondrial biogenesis. But the real breakthrough may come from epigenetic reprogramming, where interventions aim to reset the aging clock by influencing how genes related to TOR, AMPK, and their regulators are expressed. Aging is not just wear and tear, it's misregulated gene expression, often driven by methylation changes and histone modifications. Future therapies will use CRISPR-like epigenetic editing, non-coding RNA therapeutics, or histone deacetylase inhibitors to tune the master regulators of longevity without altering the DNA itself. In effect, you'll be able to dial down TOR activity in certain cells while dialing up AMPK in others on command, with minimal side effects. Add to this the integration of real-time metabolic monitoring, biosensors that track ADP/AMP ratios, nutrient levels, or even TOR/AMPK pathway activation through skin or saliva, and you'll have personalized longevity dashboards. You'll know when your TOR is too active, when your cells need a break, when to fast, when to eat, and what to take. Ultimately, this new era of anti-aging won't be about defying nature. It will be about returning to our evolutionary roots, restoring the balance between growth and conservation that our ancestors lived by. The tools will be modern, but the logic will be ancient. Stress the system just enough to trigger adaptation. Keep the cells on edge, metabolically speaking. Let the body oscillate between abundance and scarcity, growth and maintenance. That's how life evolved to last. And the future of longevity, if we're smart enough to build it, won't come from denying aging altogether. It'll come from slowing it at the switch, with science finally mastering the rhythms that evolution built into every living cell.